Perfect planning, perfect restoration. But what exactly are the optimal sandblasting parameters for secure fixation in the mouth? This is exactly the question we as a manufacturer of dental sandblasting devices are frequently asked by dentists worldwide. Together with renowned researchers at the prestigious public research university LMU in Munich, we have spent the past years working with the latest restorative materials, and together with Professor Dr. Bogna Starwarczyk and her team, we asked ourselves what contribution we can make as a manufacturer to ensure that restorations remain stable in the patient's mouth long-term. Science gives us the answer. More precisely, Professor Dr. Bogna Starwarczyk, Professor of Dental Materials Science and Dental Technology at LMU Munich.
If the restoration has been produced with great care by the dental technician or chairside by the dentist, it must also be consciously bonded in the patient's mouth. For mechanical adhesion, appropriate surface pretreatment is required, meaning that sandblasting is very commonly used for many different restorative materials.
And this is where we come in. With our decades of experience in sandblasting in the dental field and in collaboration with Professor Dr. Bogna Starwarczyk's team, we have developed the first validated system. This enables you to reproducibly and easily condition surfaces to ensure a perfect bond in the patient's mouth. The basic prebonder blasting device is the first blasting device developed specifically for your needs in the dental practice. But what exactly matters?
As part of our collaboration, we identified 3 factors that influence long-term stability of the restoration. These include constant sandblasting energy, the geometry of the nozzle, as well as the right selection of sandblasting abrasive.
This means you must ensure that these 3 factors, sandblasting energy, nozzle geometry, and blasting abrasive, are always perfectly coordinated and remain consistent. The goal is not maximum roughness, but rather to achieve an optimally high surface energy. This creates the basis for an optimal bonding surface and thus delivers a perfect adhesion result in the patient's mouth. And here's how it works. Point 1. Sandblasting energy. This depends on the distance of the nozzle and the set pressure. Having the distance alone leads to a 4-fold increase in the applied energy.
And we all know how difficult it is to keep the distance constant. With the control tip, it is easy and reproducible to blast the surface uniformly and homogeneously in the critical areas.
With the basic prebonder control tip, you not only get the perfect distance, but also something like a navigation tool. You can always see exactly where you are blasting, and to ensure that you blast right up to the crown margin, simply place the tip on the edge and start. The correct pressure determined with LMU is predefined by us. However, over time, moisture from the air may enter the filters of the sandblasting device, and then the performance of the device decreases. For this purpose, we developed this control pad, where you can simply apply the nozzle and within 1 to 2 seconds determine whether the correct pressure is still present. If you need to readjust the pressure, the specially developed pressure gauge helps you. Unlike conventional laboratory devices, the pressure gauge on the basic prebonder can be adjusted very precisely, giving you the ability to achieve perfect results at all times. Point 2. Nozzle geometry. With sophisticated manufacturing technology, innovative materials, and optimized geometry, we developed a nozzle which, in combination with correct sandblasting, abrasive, and pressure, delivers perfect results for surface conditioning. Unlike in the laboratory, where strong material removal is key, for you, it is about perfect surface conditioning. Point 3. The right sandblasting abrasive.
In a project funded by the Federal Ministry for Economic Affairs and Environmental Protection, we studied corundum. There we saw that aluminum oxide is not just aluminum oxide. They differ in size, but above all in geometry. As a result, this has a significant influence on surface pretreatment and significantly affects surface roughness, surface energy, and bond strength. If the particles are too sharp, they can even lead to fracture of the restoration material. On this basis, together with the company Renfert, we made the first decisions for selecting aluminum oxide.
With the prebonder surface Pro sandblasting abrasive, the system is completed, and finally, science confirms.
With this device, restorations can be pre-treated reproducibly. We are talking about framework materials made of zirconia, metal alloys, hybrid ceramics, and innovative, novel polymers.